All right, so we are going to go through our notes here. So Unit 1 is all about the nucleus, things inside the atom. So first off, right, all of our atomic masses are based on carbon-12, right? So most common, when we have our atomic masses, it's based on the most common isotope. And so we get a weighted average of all of the isotopes. The isotopes are relative to our carbon-12, and we use that to then get our atomic masses that are on the periodic table. Okay, so we'll say it's a weighted average. And so now, right, if we have our atomic masses from an isotopic composition, we have a formula, right? So our formula is just a weighted average, right? So the atomic mass that we see on the periodic table, it's going to be equal to the atomic mass of isotope number 1. So I'm going to say atomic mass number 1 multiplied, put our multiplication symbol there, by the percent of that isotope, so the percent of number 1. Okay, and then we're going to add atomic mass of the isotope number 2, right? We're going to isotope number 2, we've got the atomic mass of number 2, and we're going to multiply, sorry, I'm running out of room on this side, we're going to multiply it by the percentage of number 2. And we keep doing that until we hit all of our isotopes. So our real quick example here is going to be chlorine. Chlorine has 2 main isotopes, really I think just 2 isotopes in general. We have chlorine-35 and chlorine-37. So if you have an idea, right, our atomic mass of chlorine-35 is 34.97 AMU, right, atomic mass units, and it is 75.53%. Chlorine-37 is 36.97 AMU, and it has 24.47%. So something to remember, especially for some of our problems, they may not give us all of the percentages, but they all have to add up to 100%. So if we add these two up to, that adds up to 100%. That's all of our atoms. That's all of the isotopes. So if they don't give you all of the isotopes, and you're missing one of them, you may need to remember that it has to add up to 100%. Okay? So if we were to take 34.97 and multiply it by not 75, but 0.7553, and then we take our 36.97 and multiply it by 0.2447, we take those two numbers, right, that's going to equal a number. This one, right, we're going to multiply it there. That's going to equal another number. We'll add those two together, right? Our formula says that we add them together. We will get the overall mass. So if we look at the periodic table, chlorine has an atomic mass of 35.4527. What you can also notice is that 35.4527 is kind of, halfway in between, but closer to our 35, right? And our chlorine-35 isotope has a lot more, or has a much higher percentage, okay? So individual atoms, right? It's all about our number of atoms. Okay, so if we have just hydrogen, right, our atomic mass is 1.008, but our actual just one atom doesn't weigh 1.008, right? We would have an isotope that maybe weighs 1.008, and that's going to be AMU, but it's not grams, right? But if we have a mole of hydrogen, then we would have 1.008 grams. So this is the mole side, this is the atom side, okay? And how do we convert between those? We got to go down here. Okay? So, our next piece is all about the mole, okay? Let me get this oriented there. So, our mole, right, 6.02 times 10 to the 23rd items. Doesn't matter what it is, a mole of whatever is always 6.02 times 10 to the 23rd. So it can be atoms, it can be molecules, it can be tables, right? Doesn't matter. So 1 mole of hydrogen, 6.02 times 10 to the 23rd atoms. 1 mole of chlorine, 6.02 times 10 to the 23rd, 23rd atoms. It's always the same, okay? So, if we want to oftentimes then we want to use our molar mass, okay? So our molar mass, we're going to most often say that it's mm, right? It's molar mass. It can also be the formula unit, okay? And all it is it's the sum of the atomic masses. So if I have, since I've used H and Cl, I'll say HCl, right? What's my molar mass of HCl? All I would have to do is take H and take Cl, add the two together, and I get my molar mass. So hydrogen is 1.008, and chlorine is 35.4527. I add those two together, and I'm going to get 46. Okay. Okay. So then our last piece is doing our mole to mass conversions. Okay. So moles to grams. All we're going to do, right? We have our number of moles, and we're going to multiply it. Put on our bracket. We're going to have our grams up on top, moles on bottom, right? This right here, grams per mole, this whole thing is our molar mass, right? Number of grams per mole is molar mass, okay? So here, right, if we're going from moles to grams, our moles cancels with moles, we're going to get grams on the outside, okay? If I'm going grams to moles, right, I'm going to have some number of grams over here. Now I'm going to multiply it, put on my bracket. Grams has to go on the bottom, moles goes up on top, okay? Grams cancels with grams. I'm going to get my moles out. And this now is my molar mass, except that it's flipped. It's the inverse of my molar mass, okay? All right.